No,
If you
that one. Yes, that works.
Yes. Okay. Okay, let's start. Hi, everyone. My name is Siamak Paulsen, and for those who are missing me doing monthly webinars, I'm back. Thank you, Alicia and Lisa. They're also panelists on this session. This event is a hybrid event that the Australasian chapter of the IGS is running. And it's our pleasure to have Dr. George Koerner here with us, providing a presentation. And then we're going to go into a Q&A mode after that. Just as a reminder for everyone, IGS is an international society for geosynthetics with 45 chapters around the world and representing 50 countries. That has 4,000 members, almost, including corporate members, individuals, and student members. So if you're listening or watching this and you're not a member, please visit the website. I think it's internationalgeosyntheticsociety.org. And we are here in Australia, obviously ACIGS, and you can see the website down here on the bottom left corner, ACIGS.org. That is our website, and you can find out about membership opportunities, about the sponsorship opportunities, and the events on our website. And this is a picture of it. I also want to have a quick reminder about the upcoming regional conference. That's the 8th Asian Regional Conference, which is coming to Australia this time. It will be in Brisbane from 10th to 13th of June 2025. The website is geoasia8.org. And obviously you can see all the keynote speakers on this slide. We have lots of interesting presentation, lots of interesting keynote speakers coming to Australia. It's going to be a big event. So if you haven't registered yet, I think until 15th of this month, you can still get early bird rates. But yeah, don't miss out. And now, it's our pleasure to have Dr. George Koerner as our guest here in the room, as well as the hybrid session. Obviously, people watch us online live. Just a quick intro. So everyone, I think, knows Dr. Koerner anyway, but Dr. George Koerner is Director of Geosynthetic Institute. He's in charge of research, laboratory accreditation, field certification, and continuing education at the Institute. He's editor of the IGS Geosynthetic Handbook and has published over 350 technical papers in his 40-year association with polymers used in below-ground constructions. Dr. Koerner's PhD is from Drexel University in Geotechnical Engineering. He is a registered professional engineer and a certified quality auditor. George has received many awards over the years, the most notable being IFAI's Environmental Technology Award of Excellence in 1995, ASCE's Geotechnical Engineer of the Year in 2004, a title of ASTM Fellow in 2013, GMA's first Koerner Lecture in 2017, and the title of ASCE Fellow in 2020. And special thanks to our sponsors. Today we have an event sponsor that is Artafil, and the venue sponsor is Merit Lining System. Thanks to both our sponsors. Now, I'm going to start with our first presenter, Mark Amspec from Artafil. He will present a short presentation, and then we go to George Koerner's presentation after that. Please welcome Mark to the stage. Just share. And again, Alicia, Lisa, if you can confirm that you're seeing.
We can see Atafield, but not in the slideshow.
I'll try again.
Nope, still not.
F5? Is it F5? No.
Now,
Here we
Yes.
go. Yeah.
thank you.
Thanks, CMAC. I'll try to be brief. Most of you who know me will understand how hard that for me is. I do like the sound of my own voice, but I just want to give you a brief background on Atafield Geomembranes and really why we were so keen to sponsor this event, because everything we do is based around the Geosynthetic Research Institute historically. So it's an important event for Australia and ACIGS. The background of Atafield, established in Spain in 1995, first geomembrane rolls manufactured in 1997. Predominantly HDPE and LLDPE geomembranes. We've been manufacturing with uniaxial resin since 1995, bimodal resin since 2010, which is about 1/3 of what we do at the moment. The Australian material is manufactured in Dubai. It's a state-of-the-art line and you're welcome to visit. It's got a SCADA process and it's where I learned about artificial intelligence and the Internet of Things, and I'm still struggling with that concept. But I guess the key point of this workshop is modern geomembrane use is challenging geomembrane performance, and that's both chemistry and modelling and leakage rate analysis wise as well. So really the Atafield model is to use Geosynthetic Research Institute guidance to enable project-specific geomembrane life analysis. And that gives you the ability to quantify this liner, this environmental risk over time. There's a few challenges in geomembrane design, and I don't want to take George's thunder, but we see these as critical. And GM42 talks about extreme project conditions, and that's always been a challenge for liner design because it crosses that boundary between civil engineering, geotechnical and polymer expertise. So Atafield have got a team of internal chemists, and we also consult external polymer laboratories like Exelplas fairly heavily. So the other thing is, what properties do you test in a lab to try and replicate site conditions has always been a major challenge. So traditional testing really means you're isolating chemistry and temperature versus UV versus oxidation in air and things like this. And we're using parameters like stress crack, OIT and HPIT. They're really indirect measures, but we're trying to model them quite closely to establish geomembrane life. So the third challenge, and this is a big one for all designers, is how do we do this in project timeframes? And really, when true performance benchmarks are projects in situ, your geomembrane in situ, or long-term immersion testing, I know Kerry Royal will tell you 5 years is a good thing, but it's a challenging thing when you've got a project that 3 weeks to 3 months in design. So there's a need to correlate this long-term data to short-term tests, and it heavily involves what Atafield do. So I guess the Atafield solution to try and accommodate this is encouraging site coupons and encourage exhumations wherever we've got projects installed. Sort of 30 years of project history is allowing us to correlate that. So we do undertake a lot of long-term immersions on your projects. And the fundamental aim is to create site-specific geomembrane recipes. We've modelled the ageing. We try and create the recipe to suit. So the second aspect of it is project timeframes. We try and correlate long-term tests, all these exhumations, these immersions to short-term testing options. And we've spent heavily to investigate new rapid sort of test methods that George will talk further about today. Stress is a constant problem. It's very hard to account for. It's virtually eliminate or mitigate's the only option. And this is why Atafield, they replicate their resins and their manufacturing process around the world. And it basically results in HDPE geomembranes with stress cracks in the range of 5,000 to 8,000 hours, which we see as important. It gives us that minimum stress benchmark. So just a summary of projects today. We've just crossed 50 projects with site-specific analysis. correlating both short and long-term testing. So that's immersions and things like thin film. The immersions include sort of bauxite residue disposals, caustic bladders, heat leach, a lot of base metals, CIL type processes, rare earths, and coal seam gas brines of varying concentrations. And this enables robust predictions of geomembrane performance. And we're not saying they're the ultimate, but we feel like they're getting more robust as we develop better and better methods to analyse them. So, and what is at the heart of what we do is we use the GRI White Paper 6, the GRI Guide GS12 to do time temperature superposition and Arrhenius modelling to give the designer and the asset owner a lifetime prediction and the regulate. So thank you, George. We use it on a day-to-day basis, and it's a remarkable legacy of the Geosynthetic Research Institute. Some of the accelerated testing programs, and we welcome your involvement. We're building quite a large library of chemical immersions, trying to correlate long-term to short-term data, whether that be traditional pod immersions or thin film immersions. Stress crack resistance is a bugbear of ours and a bugbear of the industry. I'm interested to see what George is going to talk further about today. We find it ideal because we've got these resins at 5,000 hours plus. We've got to use short-term methods to really account for this in MQC. We find a challenge to correlate across resin formulations. So I'm looking forward to George's discussion on that. So a work we've been working heavily is deformulating, essentially fingerprinting these geomembranes. And rather than doing block OIT and HPOIT loss, we're looking at specific reaction rate loss of specific additives in the actual polyethylene. And it can give you really robust measures of project predictions. And particularly if you do it pre and post long-term immersion, you get great sense of what's driving performance of the liner over time. And we also do it pre and post welding. And the reason we do that is you can imagine you're welding at 400 degrees. You want to know what additives are being consumed at those temperatures. But all of these enable more robust predictions of geomembrane life, and it's the Atafil ethos. So really the underlying conclusion from Atafil is we embrace site-specific analysis, we pursue it, we feel like we can do it robustly and we can do it in increasingly shorter timeframes. It's not perfect, but it's improving. But all of these techniques were built on Geosynthetic Research Institute advice. So this is why these type webinars are important. Using the GM13, which has been a remarkable standard benchmark minimum for years, the new GM42 and these lifetime prediction models. So I'd say to George, congratulate the Geosynthetic Research Institute has left a remarkable legacy in the world of geosynthetics, and thank you to you and Bob, Grace and GSI, and welcome to Australia, George.
Thank you so much.
Thank you.
Okay, thank you, Mike. And with just one quick note, we go start George Koerner's presentation, and that is about questions. So you are welcome to send your questions in the Q&A box. And as George proceeds with his presentation, so you can send your questions, and we get to those after the second the sponsor's presentation. Alicia, when you...
It's not in the presentation mode yet. There we go.
Okay.
What an honor and a privilege to be here. Thank you so much for the opportunity. It is just fantastic. You have to start me. The rationale for a specification, okay? You have to make sure that we start with this at least. Types of specification, what are we doing? Manufacturer quality control. That's what these specifications that I'm going to talk to you about. Okay, so they're going to be prescriptive. Who are you getting this specification from? This should be generic, right? You're going to take one from a manufacturer? Some of them are very good. Don't let me go against that. But I think you would want it from Probably a regulatory agency, an institute, a standard organization, a generic specification. So that wants to be on your list. What's been out there? And Mark, thank you for setting the stage. Very well done. And thanks for the compliment. GRI GM13 has served us very well. Okay? It's been the standard bearer for HDPE, but a manufacturer quality control specification. The specification is broken down into physical, mechanical, chemical, and endurance properties. Mark touched on this. Look at the times, 90 days. Are you going to wait around for 3 months for this? Can we do better? No, it's hard. We met in 2018 with the objective to do better. Okay, several people were there, I believe. Alex was there. So better stress cracking, lower thermal coefficient expansion, greater durability, better chemical resistance, improved UV performance, enlarge the seaming window. That was sort of the menu that was set out in front of us. And we tried to achieve this going forward, okay, with new geosynthetics. Please realize that I'm dealing with HDPE. It's not HDPE, it's medium density polyethylene. You don't want HDPE, okay? So this is truly HDPE on the cycle after it's blended with the carbon black, which will drive up that density. And it was touched on by Mark very quickly. He called it a unimodal versus a bimodal resin, but the big advance now is this camel hump in the molecular weight distribution. Have we been trying to do that in our industry over time? Of course, we've blended HDPE with low density polyethylene for years, but not in a reactor. Now we have the ability, and we've stolen it from the pipe industry, but that's where this resin formulations come from. There are additives in here. Okay, the additives are for multi-purposes. Processing aids and stabilization packages are namely it. Okay. These additive packages, 2 hitters. The big one is the hindered amine light stabilizer. Australia is important. You guys publish things and it rattles the whole rest of the world. You are on the forefront of geosynthetic toxicity. Shakes me to my marrow, but I have to hit this dead on. The articles that came out of GNA were twofold, okay? And they attacked the stabilization packages that work absolutely best with these GRI 42 materials, okay? The Ergofox and Ergonox, and as well as the Halls, okay? These articles went all the way up to the US EPA. And there's a trade-off with these polymers, okay? And these stabilization packages are not good for the environment, but there's an idea of encapsulation which is used. In this regard to the conversation, there will be a seminar in Queen's University at the end of the month in this exact topic. We address these articles in GNA twofold, and the big hitters are down here low. HALs and antioxidants are in a wide variety of plastics, not just geosynthetics. It may make sense to consider certification of geosynthetics used in potable water or aquaculture. This used to exist in the States with NSF 60. The EPA has just offered this up to the Institute, so that might be a new venture. Wow, that's a big undertaking. Studies show that the degradation products that are discussed in these articles show up in dust. And this concept of encapsulation in the geomembrane matrix is quite a bit different than that. Okay, so this is a topic that could take this entire meeting, but we wanted to address it in this regard. Please realize that hinter-to-mean light stabilizer is in the package of the geomembrane in big fours. We then have the letdown, which is the resin plus the master batch. It's introduced into the hopper of the extruder. And then you have to confront the ugliness of the regrind, the rework. I see Graham smiling. The post-consumer material, the talc. All of these things are going to compromise the long-term durability of the material. The material that we're talking about in GM13 and 42 are first-rate materials. Okay, they have possibly reworked material in it from edge trim, but for nothing else in there. Nothing leaves the factory. Okay, the first item that I'd like to talk to you about, stress cracking. Mark, you eloquently set this up. It was very nicely done. This has been the bane of the existence of HDPE. Stress cracking is real. We've had several case histories of it. We chase it away by the environmental stress crack or single point notch constant tension load test. I've been conducting this test for 40 years. I've been polluting the environment for 40 years. The IGPAL, the CO 630, has a benzene ring contained in it. For the last 4 years, we've been trying for a replacement surfactant. We have it. Thank you very much to the Germans and SEN. And a huge cooperation from the Spanish as well in Europe, but it's under the REACH directive that this surfactant is no longer allowed to be used. The replacement surfactant is from BASF. It's a rocanol material, and it gives a fantastic response. A total of 5 round robins and 8 different surfactants were tried around the world with this. And the one that worked best is this rocanol. It worked from 3 different membranes, a pipe resin, old National Seal, which is a union carbide resin, and this is bimodal resin, a 42. And this is the matching of the IGPAL CO630 with the rocanol material. Oh, Graham is you're never impressed. So I take this is shown in a different way, but look at that R squared. It's almost too good to be true. I even see Warren smiling in the back, but this is a very nice set of circumstances. And I congratulate the Europeans very much for doing it. It's available through BASF, and I'm in charge of ASTM D35. So the single point notch constant tension load will switch to this surfactant next month. The next one was, we can't wait that long, especially for the high grade materials. So why don't we move now to strain hardening modulus? Will at least give you some ability from manufacturer quality control standpoint if you know you're in the right house. Might not be in the right seat, but you'd be in certainly the right house. And this is strain hardening modulus. It's conducted at an elevated temperature on a continuous rate of extension machine. Very prescriptive way to run the test. And you'll develop from this a load deflection plot. And you're very interested in the slope of this tail end of the curve. Okay. The steeper the slope, the better the stress cracking resistance. Okay, so as steep as you can make that, the better. This is 4 years worth of work. So this is a correlation between strain hardening modulus and single point notch constant tension load. 37 samples. Okay. It's not nearly as good as the the stress crack data that I saw. R squared is 0.74, but it's the best we have. You'll see the interception here for the GRI 50 or 500 hours, be around a strain hardening modulus of 30. 42 is up around 1,000, and that number would be close to 40. So keep that in the back of your mind when you see the rest of the specification. The Geosynthetic Institute in 2023 led a contract for $100,000 US. And it was to do the work to support this specification. Okay, good bless you. The industry participation, as well as the resins that were done for this investigation. Typically, when you age polymers, you're increasing the strength, you're making them stiffer, you're decreasing the elongation. Shown a different way is here. So many days of exposure, you have an increase in modulus, an increase in strength, and a decrease in elongation. Mark said perfectly, it's just taken too long, George. We can't wait 30, 60, 90, 120 days to see this. We need to do something at this 30-day mark in here. Okay, so that has to be the threshold number. That's just about as long as we can wait. Materials that were used. So now there's a leap of faith. These materials in their conventional thicknesses can't possibly be tested in that short a time frame. So what we're taking is taking these materials, grinding them, and then creating a plaque of a thin film. And now we're going to do the exposure on that. Oh, I see some long faces. Maybe people don't believe. You must be very good at this. You need to make that plaque very well and have a very keen interest on this. You can crush this material. Please realize that a lot of these materials are made either on blown film or cast lines, and they're multi-layers. So now you'll grind this, one of three methods: torque uriometer, cryogenic grinder, or two-roll mill. You'll take this and then form a powder and then create a plaque. And 42 does not stand alone. It takes 40 to make the plaque, and then 41 you'll hear about just in a minute. But this is GRI GM40, and this is making that 0.25 millimeter plaque. Okay? You're going to take that film that you made during this plaque, and then you're going to start by annealing this. You'll have to take the baseline OIT. And the OIT is not an or now. It's an and. So you'll do standard OIT and high pressure OIT. You will then take that film and anneal it. This annealing process is reagent grade water, very clean water, and it's in 85 degrees C for 2 days. You will anneal that material, and now you will do the exposure on that material. And there are 3 exposures. The first one is oven aging that you're very familiar with at 85 degrees C. You're doing it for about 15 days, 2 weeks. And you have the OIT at time 0, and you're going to compare that with OIT after 350 hours or 15 days. That's what 35 samples look like. The thresholds are drawn here, and you'll see it for standard, it's 55%, and for high pressure, it's 80% is the threshold. There's a couple weak children in there. Number 8, number 18, number 25. keep those in mind because you're going to see them 2 more times. But they are GM13 materials. So they were the ones that we would know would fail. Okay, but the system seems to be working. Some very good ones we know in there, but that's all hidden. The next is probably the best of the weathering test, in my opinion. It's UV fluorescent. It's typically done in a QUV device, weatherometer. It is controlled with calibration and internal reference materials. And unfortunately, you can only run high pressure OIT on this. You don't run standard on this. And here you see the percent retained. Standard is not recommended, and there's a 50% retained here for UV fluorescent. That threshold, remember 8, 18, and 25. Yeah. If you would take the base resin without the carbon black stabilization, you would cut it to quicks. You would just deteriorate the material straight away. It's a very powerful test. The next, which is not akin to GM13, is chlorine. Chlorine is only run at 50 degrees C. Those that remember chemistry, it's a halogen. It's an aggressive material to any olefin, and it is at 10 ppm solution. Again, the series of data here, you can run standard and high pressure. And again, it works very well if you look at 8, 18, and 25. So we have a way to challenge this material on a short-term basis quite effectively. In addition to that, thin films can be analyzed quite readily. They can be done in gas chromatograph mass spec, and they can also be analyzed with FTIR. So to your liking, much more easy with the analysis with thin films versus the entire membrane. So you have extra forensics that are available to you. So the specification now covers high density polyethylene. Please realize 0.945 or better. Thicknesses, smooth and textured. How do we do versus Munich? Better stress cracking resistance. Got that one easy. Lower coefficient of thermal expansion and contraction. Yes. Greater durability. We think so. Better chemical resistance. Yes. Improved UV performance. I was hoping Fred Gassner would be here because we were in Munich together with him. I didn't get an enlarged seaming window. Believe it or not, the seaming window is more compact with this. It'll be harder to install because of that. The seaming window is not as large. And I see the Leicester fellow shaking his head, so we're in agreement with you. Okay, so this specification, I realize this is rather small, but the stars show you the change versus the GM13 number. There are no thin millages that are allowed here. 1.5 millimeter is where the table starts. Okay, so all the thin millages have been removed. The next thing is the density. The density is higher than what was broadcasted in GM13. You have to give up something, and one thing that you give up is the break elongation value. So that's only at 500%. Okay, that's not as long, not as big. Stress crack, it's up to 1,000 hours. Strain hardening modulus is at 37 megapascals. Okay, carbon black is 2 to 3%, but the carbon black dispersion is either category 1 or 2. There's no allowance for category 3. It's a better quality carbon. You have an and for standard and high pressure. It's run on everything. And then it's 3 different things: oven aging, UV, and chlorine testing. And I've shown you the data for that. So it's a new day for this material. I should talk to you about every specification for geomembranes. All 13 of them have changed at the Institute. They used to be covered under a seaming specification of GRI 19A and 19B. This will all be depreciated. Each one of the seaming characteristics will be in an appendices to the specification, and this includes GRI 13 and GRI 42. Okay. The appendix, I don't know if there's a lawyer in the room, but in the States, the appendices, you cannot be held to. So in the body of the text is what a manufacturer is liable for, and that's how you absolve yourself from the seam specification. That is extremely important. Okay? The responsibility of the seam is the owner, not the manufacturer. It's a nice fine point. Called out 3 different items: strength, deflection, and locus of break in both the ASTM and ISA. Everything will be moved to the appendices. I spoke to this and will depreciate 19A and 19B. I was asked to talk about the future of GSI. Mark, you gave me such compliments. It is changing. I will step down as director of the Institute next year. So this is my last year as the director. Our mission is certainly to service the member companies. So what will happen to the Institute? The Institute is very active. GSI is the mothership, and under its umbrella is research, education, information, accreditation, and certification. The research is extremely active, but the big emphasis for us is durability. And you can imagine a lot of work has gone into making these specifications, and I think it will continue with that going forward. In addition to that, education, we gladly do this. Thank you for the opportunity. It's a real privilege to speak to so many and so far around the world. We just take the opportunity any chance we get. As far as information, our biggest effort is in the IGS handbook. This will be available. I'm editor of that. This will become available in September at EuroGeo. So you'll see that. The accreditation is now well over 130 different laboratories around the world. It keeps me in frequent flyer miles. I'm here for 2 laboratories, Geofabrics and TRI, over the next 2 weeks. The next semi-annual audit will be in Toronto in June. You're welcome to attend, but this program has done very well. As far as certification is concerned, there are 2,500 inspectors. Next week, there'll be a course at TRI, and they have a group of people that will take the exam. But this is where the rubber hits the road, where you have CQA inspectors. Affiliated organizations, we used to have Taiwan. They no longer, Wayne Shea retired. Professor Zhan at Inha University is GSI Korea. GSI India is very strong with Betra. And now GSI Brazil has just come online. So Georgia Tech will move forward with that. The transition will go down to Georgia Tech in Atlanta, Georgia. It's the #1 geotechnical school in the United States. So it has support from WSP and SGI, which are 2 laboratories, quite strong. A fellow by name of David Frost will be the new director of the Institute. This came about by a year-long ad hoc committee. There were 12 that participated in a written proposal, response for a proposal. 4 people were given oral presentation, and the winner of that was Georgia Tech. Georgia Tech, this was announced in December. Public announcement at ASTM in Houston. Letters have been exchanged, and they're having regular meetings. Public announcement in Louisville. Alex and I were there, discussed at the board of directors, and the board of directors will all move down to Atlanta for a May meeting to see this transition take effect. The vision for the future is to relocate from Philadelphia to Atlanta. They'd like to expand the membership grow the 5 areas, refocus on research. They'd like to add 2 new institutes, one for climate change and one for artificial intelligence. They think this is the way of the future. Expand international activities and certainly sustain the legacy of Bob Koerner, the founder of the Institute. Think of this as a nonprofit. So it's just moving locations, but certainly we'll stay active and grow going forward. This is exciting times for geosynthetics. The new facility will be right on campus in downtown Atlanta. It's a little unfortunate it's on Main Street, but 600 Main Street, there will be the offices, and they're appropriating space. This is a bit small, but there are timelines through this. I've promised to stay through 2027, but this is how they'll transfer the operation going forward. I'm yours. Thank you so much.
Okay, so we quickly go to Merit's presentation and then we start the Q&A with George.
It's, yeah, thanks, all good.
Thank you.
It's the space bar.
Yes. Or WordPads.
So good afternoon, everyone, and welcome to today's hybrid workshop. My name is Alex, and for those of you who don't know, I work for Merit Lining Systems. We're a geomembrane installation specialist based both here in Brisbane and in Perth, and we've been working in the Australian lining industry for roughly 35 years. In that time, we've come across a range of sectors. We've worked in a range of sectors. Obviously, the mining industry, civil and commercial infrastructure, and the agricultural sector. We've seen many different specifications and designs, as well as many projects with no spec and minimal design. As a lining company, our top priority is providing and ensuring high quality work and professional advice where we can obviously advise our clients. While most people in this room are likely designers, MLS are typically not. We do, however, pride ourselves in providing reliable recommendations to our clients. Since there is no overarching Australian standard on geosynthetics, we rely heavily on the Geosynthetic Institute, and most notably GRI GM13 and 19 to date. We believe today's topic, geomembranes in extreme conditions, highly relevant in the Australian lining industry, and as such, we're happy to be here for this workshop. An introduction into GRI GM42, geomembranes in extreme conditions. To open things up, I have a short case example of a lining system subject to extreme conditions over its working life. You'll see it behind me here. This was a recently removed and replaced liner in Perth Metro, obviously quite a hot climate. So you see the scope on this project was to remove a 20-year-old lining system. There was roughly 17,000 square meters to remove. The liner had exhibited stress cracking at multiple locations and resulted in leaks throughout the primary geomembrane. This was then replaced with a new high-spec material, and the outcome of this was that the high-spec was tested to over 1,000 hours stress crack resistance. So one of the items that George noted on the GRI GM42 spec. Several challenges involved in this project was the removal of 4 layers of material, decommissioning an old redundant outlet structure, and the addition of a seepage point that we need to install. So first off, we had to remove the liner and desludge the effluent pond. You'll see on the right there what the effluent looked like. This took about 4 days of washing and vacuuming using a sucker truck. We had a 10,000 litre sucker truck on site. And in the background, you'll see the materials being removed there. So we were doing that by cutting up the material into manageable pieces and then taking it out with a telehandler and placing it in skip bins. To manage the waste, we had regular skip bins almost daily to keep everything off site. Additionally, we had to remove the geomembrane from the anchor trench. So you see there was 550 linear meters of anchor trench we had to open up. And in that trench, there was an existing water line, which was removed from the trench. You'll see some progress shots here. These were taken just prior to Christmas. On the left there, you'll notice there's a bit of a concrete structure and an excavator with a rock breaker on it. This was an old outlet structure we had to decommission. And here's a photo just following Christmas, prior to lining install. So this is the old outlet structure our client asked us to decommission. In order to do this, MLS designed and built an engineered core filled retaining wall. You'll see it on the left, that's where we started. On the right, that was about a day later. Following that, we actually backfilled the void with limestone and finished off with stage sand to provide a smooth surface. You see on the left there is the limestone and on the right, the stage sand. Another challenge we had was installing the additional seepage point. We had to locate a pipe underneath 500 millimeters of concrete. To do this, we used a probe, exposed the pipe without damaging it, installed a new riser, and then had to install Rio and concrete to finish off the seepage point. So now to the lining works. You'll see there was 4 layers in this pond. We had on the left the first layer geotextile, on the right a secondary HDPE 1.5 mil. This material was stress crack tested to 1,000 hours and ELI tested over its entirety. The next layer we had was geocomposite as well as GCL strips, which delineated 4 leak zones. I don't know if you can quite see them there, but you've got one that runs up the low flow channel and then 2 across the pond there. This allowed us, or this allows the client, if ever there's a leak, to identify what zone the leak is coming from. On the right is the primary conductive, which went over the top, and this liner was again stress crack tested to over 1,000 hours. It was a 2 mil product and conductive, which allowed us to ELI test the final layer as well. Lastly, we installed permanent ballast at 200 kilograms a linear meter. This ballast was installed directly above the GCL to provide a confining pressure. Should ever there be a leak, that means the GCL can swell in that area and will allow the leak to be delineated to the different zones. In total, there was 18 leak detection points across the 4 zones. Lastly, this is the pond complete at the end of February, just here on the left. And our client asked us to undertake a 24-hour hydro test, which we completed. Following the test, we were able to determine that the pond was leak-free. Yeah, thank you.
Now, playing here, what I might do, I just Alicia, you can hear me still?
Yes, all good.
All right, so let's start with a question from those attended online, and then we probably go one online, one in person, to be fair. George, if you want to maybe sit next to me, I'll just move that chair. People can see you as well. All right, first question by Eddie. That's autofill. Okay, so I'll move on. Density greater than 0.945 gram per cc is.
Yes, that's the new specification. It's a slight bump in density. With that, you'll get more crystallinity. And from higher crystallinity, you'll get better chemical resistance. So that's the benefit for higher density material.
Sorry, can I ask a question on the same subject?
Sure.
I don't know if this.
Oh, come on, Warren, don't sell yourself short.
We can't hear the questions from the background,
Carbon black
so someone will need to come.
number, or is that separate of?
Warren asked, does additional carbon black, will that bump that number up? Please realize that the carbon black is still 2 to 3%. So that's the formulated value. So that has been taken into consideration. It does not, though, take into consideration the titanium dioxide in the white membrane. The specification is silent on that, but good question. It's formulated density.
Very good. We have a question from Eduardo Zanoni. He's in South Africa. So, hi, George, this is great. Those test methods readily available throughout the world in a normal chemical specialized laboratory. What if the 0.74 R square makes the geomembrane fail? Would GM13 still apply?
Yeah, this is a total departure from that. What you're doing is it's all based on thin films, and you're being asked, or you're asking, is that readily available? Please realize that both the standard methods for standard OIT and high pressure require it to be conducted on thin films. So that's available in laboratories. You need the scale. You need a pretty large specimen. The specimens are typically 150 millimeter by 150 millimeter by a minimum. So that's a pretty large placking system that you have to make those thin films. But they're available throughout the world in polymer laboratories. The 3 tests of an aging is simple. UV fluorescent is a specialized device. And I should caution you on keeping the 10 ppm consistent over 2 weeks. That is not an easy trick at 50 degrees C. You'll need to test this at least weekly and probably bi-weekly to make sure the potency of the 10 ppm. Anybody that's ever tried to operate a pool knows this. Keeping chlorine stable is not easy. And that's also the rationale for not jacking the temperature up higher, because it would lose even more stability at higher temperatures. So great question.
Very good. And thanks, Eduardo, for watching us from South Africa today. Any questions from the floor? Alex, I'm looking at you. You just came back from Geo Frontiers. Maybe tell us a topic, a hot topic that was discussed in there, and we can maybe talk about it here too.
I guess the hot topic or the hot takeaway for me from Geo Frontiers in the US was also the applicability of high performance geodes. You know, we focus so much on high performance geomembranes, and the geonets aren't necessarily engineered with that same focus. That's
Sure.
something that Ontario was did a very quick overview on.
Cool. I'll just quickly repeat because this is the microphone on the laptop only working. So the question or not, the topic actually that Alex mentioned is about high performing geomembrane as well as high performing geonets. And this is a topic that was discussed in GeoFrontiers in the US. George, your comments?
There's two new specifications at the Institute on these materials, one for turf reinforcement mats and the other for drainage products, addressing some of those concerns. Let's be forthcoming. A lot of regrind scrap has been put into the nets and drainage composite cores over the years. And are you concerned if they crack into little pieces for long-term performance? If I'm using it as a detection zone and I was a government agency, I would like this material to stay the same over time. And I think that,
Yeah, if you're aligned with a tailings dam, so on, you're trying to de-water, you want the same drainage performance through the life of the dam.
so we want high performance QC materials for those applications.
All right. A question from Pei-Cheng Teo, and I know she is in Malaysia.
Oh,
So we have
hey.
people watching us from there. Hi, Pei-Cheng. Question, Dr. George Koerner. Do you have the correlation data of GM13 versus GM40 and GM41 in regards to oven aging and UV resistance?
Yes, I do, but I can't share it with you. They all signed up anonymously. So yes, the data is all there. Maybe we have a beer to no, but I promise not to share the data. It was all done anonymously, but the data shows that these bimodal materials certainly outperform the monimodal or unimodal materials in a significant way. So it's an advancement. What comes to mind, though, in a very honest way, is do you need all of that? GRI GM13 materials have served us very well. And think of it as a tool, not one that's used everywhere. You don't need a Ferrari to get from place to place. There are many applications that are not requiring this. Alex showed a very demanding application, and I'd love to see a little bit more where those stress cracking problems were, if they were around the seams.
That was around the extrusion welds.
Extrusion welds where you had elevated uncontrolled heating, you know, at those locations. So and people are discussing this, but you don't need high performance, and there's a cost associated with this as well. Please realize that there's a difference in GRI 42 versus 13 cost-wise materials. So there has to be a benefit associated with that in an extreme condition. And I hope we pointed that out, but your question certainly addresses that. And good to see you. Thanks for being with us. She's a talent.
Yeah. Yeah. Question from the floor. Graham, it's your turn.
We've had issues here, George, with white materials having a high density because of titanium dioxide. The resin is the same resin as the black material. Do you have any experience of that? Comments on it?
Yeah, it's ash content.
Repeat the question.
The question is materials that are stabilized with titanium dioxide rather than carbon black. The density of the material being different And also, you're not measuring the carbon black content anymore, you're measuring the ash content of the material. Not speaking out of turn, you have to really worry that is it titanium dioxide? So we see talc in these materials quite often, and that will improve the short-term properties, but compromise very much the durability of the material. It can be added into the formulation as much as 5%. We see it in the 2 to 3 range often, but that is what changes the density quite a bit. But there's a density consideration, and then there's also a ash consideration. The way to handle it, though, is to section the material and test each layer in isolation.
And that's a problem because titanium oxide and stabilizing titanium oxide, you often lift your head at amines, but with talc in it, you got a problem.
Another question?
Sure.
Sure, stay here all night.
Do you have an opinion on conductive geomembranes, whether you should test the entire profile or just the non-conductive element of the geomembrane?
Oh, that's a big one. Let's hit it first with the question came with conductive material. This is usually a thin film on the material, and the first item of concern is stress cracking. So what side are you going to slice? This has to be negotiated pre-test at what side you're going to go after the material. It gets more complicated when you have EVOH in the section as well. So EVOH is very susceptible to stress crack. So if you nick that layer, it will be pronounced. But you have to agree on the protocol before you go into testing, and it matters. And I think you know that too from experience.
Very good. Going back to the online questions, and interesting, we have viewers from New Zealand. Jonathan Shamrock in there.
Oh, I know him too.
He says, thanks, George, for the presentation. Can you run over the fate of GRI GM13 again and how that will now be covered by the material spec as an appendix? Any thoughts on the new ASTM welding spec calling for data logging of welds and the possible ACIGS installation handbook?
Sure. We just had the second session in Louisville. The room was packed for the seaming session. So the first question you asked was in regards to the depreciation of GRI 19A and 19B. 19A is for thermofusion non-reinforced materials. 19B is for scrim reinforced materials. So the test method for the non-reinforced materials is ASTM D6392. That is the method, and it will be called out in the appendices of items like GRI GM13, 17, the polypropylene 1 and 42. It'll be placed in the appendices. And the other one are the scrim reinforced materials like chlorosulfonated polyethylene or reinforced polypropylene. They're all tested, again, 25 millimeter samples, ASTM D7747 test method. But again, placed in the appendices, so there's no confusion. There was quite a bit of people were getting confused of what standard is applicable, and now this will be seamless. And the appendices, I spoke earlier that's not official. And we found that out from our 3 different attorneys who looked at it with inside the Institute. So the next question you asked was in regards to, sorry, I missed the second part of it.
That's so sorry, I just scrolled down. Thoughts on the new ASTM welding spec?
Oh, they're active. We have folks from Leicester in here. Eddie Visor was on the panel. Alex was in the room. I believe the room was full. We had a meeting in Toronto as well as a second meeting in Louisville. Things are very active. The winner of the show, I thought, was Ed Zimmel with his extrusion welds, and we found out from Alex here that it was that's where the action is. So you really have to standardize it. The big item there is the ductility in the weld. You cannot have the weld snap, but there's experts in the room that know it better than I. But thanks for asking.
Great. And from the 120, almost 120 online people, if you want to ask a question and you want me to open your mic and you can ask directly, just send a message in the chat box and I can do that too. Now,
You have Jacques Coutet on there.
I was going to say,
Oh.
where in the world Jacques is, I don't know. It's somewhere in Europe. I don't know what time it is in there, but hello, Jacques. The question is, by powderizing the liner sample, aren't you overlooking surface properties and their impact on geomembrane lifetime, like LL resin or white additives, and overemphasizing the core resin?
We are making sausage, and it's a compromise. It's a huge compromise. And I was very forthcoming of this leap of faith with this thin film. But I submit to you, it's the best we can do at this moment. Somebody going forward will be more clever than I to give you a solution, maybe section these layers and test them individually. But we can't at this moment. This was truly a compromise to the placking of the material, but this is where we stand at the moment, and we'll have to let it run a couple years. Let's hope they perform very well, the 42, and don't give a couple failures going forward. That'll make me eat some crow. So
Well, I think it's important to highlight, George, we're already doing that oven aging anyway. So we've already got the white black challenge. You said the accuracy is paramount in terms of the ratios and the milling process.
Mark, good point. I think you need to make a good plaque, and we need to get some experience here and some shared experience, and which has really been fantastic. And I have to compliment the Australian chapter. These are very important. I mean, you have a host of people online from around the world with this. Thank you. What an opportunity. Nice to be here.
Thank you, George. I have one more surprise for you, George. Guess who? Boyd Ramsey is online. Let's read the question. In defense of the GeoNet/GeoComposite material, there is a huge difference between the failure of 1, 2, or more not joining intersections and the failure of a barrier geomembrane. Yes, a great deal of reused material goes into GeoNets, but I would suggest that this reuse is a critical component of sustainability activities and a good place to use more recycled material.
Yes, you worked for a manufacturer for a long time, and that's the practical side of things. Yes, I agree. There's a point and counterpoint to most things, but drainage is important, and to keep these, especially with double line facilities, this witness zone needs to work. And okay, you made a point.
And and we're talking about extreme conditions here, which, most of the applications are mining, brine and tailings and that sort of activity projects. So I guess quality is the most important thing there. Let's take a question from the floor if anyone.
Material supplier. Earlier, obviously, suppliers and owners warranted the material, but the welding seems to become owned by the actual owner of the end owner, shall we say. How can we correlate between the material supplier and the machines or installers? We can get a closer relationship with prescribed parameters or not to exceed certain temperatures or, shall we say, pressures, or just the parameters around it. I'm going a bit.
No, you asked, but the answer is automated welding.
Just the actual prescribed from the material manufacturers themselves, a set of parameters that are suggested, not.
There's an arms race going on now in seaming. And there are welders now that are seaming at temperatures that frighten me. From the perspective of, we're going to start seeing stress crack problems in fusion welding pretty soon if we keep going like we're going. We have to slow down, use lower temperatures, and they're talking a lot about thickness, the controls of the material, but the seams have to be done right. And just to get them done quickly is not the way to go. A lot of discussion in Louisville and Toronto about automated welders, monitoring temperature, speed, and pressure. And I think that's an advance. And you're right. The owner will assume, it's not the manufacturer of the membrane, will assume the quality, and the bridge of that will be the CQA. So the CQA will become ever more important in that regard. Good question.
Can I make a comment on that?
Of course.
We do a lot of structured seam testing. And at the moment, the standard doesn't require a thickness of that, particularly the double fusion weld. It doesn't require a minimum thickness of that weld. And I think that's a shortcoming of the standard, and there's a missed opportunity with the new ASTM standard to put that in there. But the easy way to make a deep structural seam fail is to squash it down to a crazy thickness, and it will pass the deep sea. You won't get AC air breaks into your system, and I think that's the thing that needs to be switched out.
Yeah, when they break like peanut brittle, and you get the strength, you are doing that's a disservice.
And us as a lab will never report on that because it's not a requirement to report on.
And that was one of the points. Quite a single in the workshop.
Ed's on the line too, by the way.
But with as an industry, we've focused completely on productivity from a welding perspective. So hot up after without taking into consideration on what the effect is on the structure of the material, compared with raising the fact that back in 20 years ago, you were always looking for a ductile failure in the well, not in the well, but adjacent to the well. And the number of times now we see essentially a brittle break at the string of the well. So there's no break, there's no penetration into the well. But it's essentially a hit all the numbers that would snap like like a peanut brittle. And that's one of the things that I guess the industry should be looking at.
Well, I've added a clause into all the seam specs for that Ian Pegg's Henry Haxo film tear bond, the ductility, but then went to Geotechniques, which is a firm that does a lot of this. And then how can I spec that? That's not a speccable property. So, I'm very far away from doing elongation on peel tests. So not a straightforward answer to you.
Just because Eddie's name came up, so I asked a question from him. He's sent maybe 2 or 3 so far. Why does the company not supply any welding parameters for the installer? And the second, if the welding seam is the responsibility of the owner, and how can this be reliably carried out when the manufacturer does not give any guidance about welding parameters?
So they want to absolve themselves from that. If I was an owner, I would walk away from that. I'd probably tell them, and we have folks from Leicester in the room that have that matrix chart, you know what they are roughly, and it's a seaming window, or Eddie Visor talks about a seaming triangle that's there, but that's not the responsibility of a manufacturer. They don't want to commit to that.
And the other thing is that as a manufacturer, how do we take into account the ambient weather conditions and so on? If it's a black geomembrane versus white, so the sheet temperature could actually be like 70, 80, 90 degrees Celsius, just laying out in the sun. How do we take that into account when we're nominating flowing fronts? Yeah, of course, no, we understand.
Can we go back to the talk about density of the geomembrane? So Ryan Hackney, he's on the Gold Coast, not too far from here. He actually, I'm pretty sure he wanted to be here, and he started this conversation with you, George, but he had family visiting from overseas. What if a geomembrane with density higher than 0.94 and less than 0.945 passes all durability challenges and other specification requirements? Does it just fail on density?
Yes, it's a GM13 material then.
Yeah. Okay. Easy. Let's go back to South Africa. Jabulile.
Oh,
Pretty sure you know
hello.
her too. Hello, Jabulile. Thank
wow,
you.
You have quite a crowd.
Yes.
It's amazing.
We still haven't dropped under 100, and we keep going with the questions. Thank you, Dr. George. You have any data regarding durability of exposed geomembranes for comparison on conductive and unconductive? We talked about it a little bit. The case study shared by Merit Lining has sparked this question. Also, what's your opinion on exposed liner on pollution control of dams? Should be not fully covering these?
Yeah, there's quite a range of products that are being used on dam and dam faces exposed. I'm very familiar with the Carpi products that have a niche in this business, which is a very thick 300 millimeter PVC geomembrane that's used in this application. As far as the conductive material, their durability, some are very good and some are terrible. Let's face it. I have several case histories that are just atrocious. First, you need a test method that challenges the conductivity. It's really the resistivity of the material. There's a GRI method for this, but it is not being well received with inside ASTM. But there certainly needs to be a separate specification for conductive materials. And we're working on that now, as well as working on EVOH, but that's work in progress. The durability of that is a very hot topic at the Institute.
Great. One more from the floor. If WSP representatives have any questions, we have designers Sam, Bianca, and Mel. Sophie, sorry. Any questions from you, or you have Lisa actually online? You can open your mic. And
I had a question. Hi, George. I had a question earlier about, and I think you basically answered this, about this whole plaquing thing and having multi-layer materials like a conductive layer and how that influences the actual result that we get and how representative the values are that you get out of your testing in terms of the longevity of the material or expected longevity of the material.
Yeah, a couple of items is to make it worst case. It is not perfect, but it certainly is a worst case scenario, and thin film, so you get the answer quick. It would be better if you could section the material and do the layers individually, but this becomes very time consuming and hard to do. But it's the best we have at the moment. Any ideas? We would be keenly interested in the way to conduct it better, but this is the best we have at the moment. So in the long term, you would still actually want to do the full exposure testing to the actual material? No, there's no full exposure. That's done in the field in a separate instance. This specification is released. All the durability tests are done on the films. Yeah, but if you wanted to actually test it properly in terms of its real performance, you would do it as a long exposure test with the material without it being flat. Most definitely, and it would be Arrhenius modeling, and it would take years. I'm talking the Arrhenius modeling that we had took 12 to 18 years, depending on the materials. So very long exposures. We don't live long enough. We don't, and it's certainly outside of the realm of a career, which is like 40 years. Certainly.
So between GRI 13 and GRI 42, would there be a large cost in testing? Say you wanted to independently verify the material, would there be a significant cost between testing between the two types of geomembrane? Not much.
Sorry, the question is about the difference in cost between testing material in against GM13 and GM42.
Yeah, the addition would be a longer stress cracking time. Obviously, that would cost more. Strain hardening modulus, which is a test done off of a dog bone test. It's done, quite simply by a lot of laboratories. And then the 3 exposures, but shorter periods of time. You would have to make a plaque, but that plaquing equipment that's available in every polymer laboratory.
George, sorry to interrupt, we've quantified this. The material and weld costs are going to be the obvious costs. Testing is, to these methods, I was just doing some sums, timeframes wise, it's going to be here nor there, I suspect.
Yeah, there'll be plus and minus of the testing. Some pay will cost more, but others will have time less machine time. But yeah, the material cost, biomotor resin, significant more expensive than the raw materials.
Nice to have practical people in the room.
And welding, we were talking about ductility before. Everyone wants a trial weld to pass quickly. They don't want a slow cooling ductile weld. It gets great shear results, peel results, but takes time to cool. So you're going to have to factor a lot of these things into it.
Good question. Thank you.
Thank you. For those of you who are asking how long we're gonna go for, maybe another three questions.
Sure.
Hopefully quick ones.
Not leaving tonight.
One more from Malaysia, Colin Lim. Thank you, Dr. George. Just curious if there is a reason why an assumed yield stress is mentioned explicitly in GRI GM42 for SP and CTL, since the footnote has already indicated that the yield stress should be manufacturers.
Colin, you always love people that read your stuff. So you're a practical man. You're on it. Yes, there's too much monkeying around with the stress crack test. We wanted to take the ambiguity out of it and just put one yield stress. That was the average we had of the high performance bimodal resins, and we stuck to it. We have not gotten pushback from the industry, so that's the first blush. If you have complaints, we'd like to hear from you. So, but yes, that's you've read the minutia, so you're in the weeds, so to speak.
Okay, good. One more. Yeah.
And so there's a note in there around manufacturers doing a formulation study, 20 tests each. How does that correlate to the assumed yield, if you like? So formulation.
I have not heard pushback from this.
Okay.
So this has been out there now for a year. So but we'll take a wait and see approach. And please realize these are documents, these are not records. These get updated and change on a regular basis. GRI 13 has been through 19 revisions.
Great. Some people are asking to repeat questions. We try and do that. So the start of every talk, we repeat the question anyway. A question, I go to this one. We had a question from India, if I'm correct. So there we go. Thanks for the webinar. I am from India. We have one question regarding chlorine aging for preparation of 10 ppm chlorine. Which chemical we use? Explain briefly, please.
Oh, it's inside of the standard 41. The chlorine is prepared in an aqueous solution. We have best in sealed mason jars. The trick with the mason jar is to use a 1 liter size, mix the chlorine, which is in powdered form, with distilled deionized water. The mason jar, though, you need to place a protective film over the seal, and then invert this in a water tank. That works best for us. We rotate the samples every 3.5 days. We check them and we refresh them so it's 10 ppm. You check it with a conductivity probe. Will give you the correlation to 10 ppm. It's right on the money.
Yes, about the chlorine, because we were doing like immersion testing with chlorine also with our university. They were doing the immersion and we were doing some testing of rationale
Sure.
agent. They were sure that the chlorine is evaporates at 30 degrees. That's why we were doing like only room temperature and 30 degrees. So, but it was a long-term immersion. It was not as short as is in this new specification. So we were surprised because the temperature in the chlorine testing is 50 and 50 degrees. And I don't know if it's because it's considered like it's not going to evaporate because it's not as long as the immersion that we were doing, or
maintain your concentration,
exactly.
short term,
The TPM that you have in the, or it is because of the the film to
So you have a container. This is,
Can we just repeat the question?
the question is the stability of the chlorine solution, which is very good. And I take a plaque of the material. The trick is with the plaque, you cut it, you fold it into a cylinder. So you have two grooves, and then you place it in the water. This is the chlorine solution, and it's 0 headspace. So you fill this up and you place a seal on this. There's no air whatsoever. And that's the trick. And then you take this, you make the seal, you invert it, and then place it inside of a water bath. So that's how you keep the chlorine in suspension. There's no headspace for the chlorine to evaporate. Oh, every 3.5 days, you take it out and you make sure that it's 10 ppm. And there's a hot debate on your question. Professor Rowe does not believe that I can keep it at 10 ppm. He thinks it's too high. So he would like that to be much lower.
Good test.
Good test. The halogen bromine might be better. That's what we're working on. But if you remember your periodic table from those halogens are very reactive to it. And the actual solution, if you go to a pool supplier, you can get raw chlorine that is more stable. It gives a percentage of chlorine that stays in solution. Sure.
Great. Okay. I think that was
You only knew these things by doing it. So they really are brutal to learn.
Thank you. And yeah, I think that's what we have time for today. We're just right on time at the 2 hours that we promised everyone. So thanks for attending. Just one final note. That's again repeating about GeoAsia conference coming to Australia 2025. That's 10th of June. The website is www.geoasia.org. If you want to know more, please visit the website and register. Alicia, Lisa, if any comments from you guys, otherwise we wrap up.
No comments. Thank you.
Just want to say thank you very much to George. It was really, really good to hear all of this. Lots of things to think about.